Hello, we are Project VHUD. Our team members consist of Ryan Herzig, Ashton Santee, Ethan Witt, and Matt Radford. Our internal advisor is Dr. Sergio Daskalou, and our external advisor is Mr. Richard Kelly.
Modern science fiction and fantasy cinema has inspired futuristic technology that features clean, minimalistic systems laden with staggering amounts of data. Imagine movies such as Iron Man, Independence Day, and Minority Report, where characters control their equipment through their heads-up displays. VHUD, or Vehicle Heads-Up Display, seeks to create such a system for modern vehicles by removing the dashboard and directly displaying all a driver's data directly on the windshield. A major problem with modern vehicles is that the driver has to look away from the road in order to read the dials and gauges in the dashboard. The goal of VHUD is to effectively eliminate the driver distraction presented by the traditional dashboard and create an integrated experience between the driver and the vehicle. This can be accomplished through three pieces of equipment: an OBD2 Bluetooth adapter, an Android tablet, and beam splitter glass, a special type of glass used to reflect a larger percentage of light back to the viewer than regular glass. This is commonly used for teleprompters. OBD2 stands for Onboard Diagnostics version 2. The OBD2 adapter utilizes the diagnostic port, which has been built into almost all vehicles manufactured since the early 2000s, which can be found under or near the steering column. While it is normally used by mechanics to diagnose an engine malfunction, we have interfaced this information with the tablet and beam splitter glass to display vehicle data on the windshield.
This was one of our first drafts of what we thought the GUI would look like. We thought that a navigation system would be up in front in the middle of the dash with a basic miles per hour, speed limit, traffic, and other such directions there easily seen on the screen. This was our first version of the Quick Dashboard GUI. As you can see, much of the same data is here as it is in the final version, but much less pretty. It also began the idea of color coding specific information to make it easier to see in your peripheral vision. This was our next GUI for what the Quick Dashboard would look like. We switched color schemes to a black background and bright text, that way it would be optimal to see in the reflection of the glass. We also incorporated a reverse text button that would allow you to front the text if you were displaying it not on the glass but in real view. This next iteration of the GUI for the Quick Dashboard saw the biggest change yet. We changed from dynamic text boxes to now do dynamic graphical representations of the speed and RPMs. We also added a graphical representation of the engine temperature and fuel left in the car. This GUI was designed to be more convenient and easy to read for the driver's peripheral vision. It was also much cleaner than our previous ones. Here we come to the final iteration of what the GUI looks like. We enlarged the gauges for the RPM and speed to make it easier to see, and we added a new maps to show you where you're going and where you've been. This will also include directions. We also added an ambient temperature to show you the temperature outside underneath the engine temperature. Upon selecting the app, the user is greeted with a menu containing all of the options available to them. Let's walk through each of these options. The first option in the menu is the Quick Dashboard, which aims to be a simple and quick accessible alternative to the modern dashboard. As you can see, the available information is the driver's current speed, RPM, engine temperature, and remaining gas. The customized dashboard is a listing of useful OBD2 data that is selected by the driver. As you can see, some of the information includes speed, RPM, timing advance, barometric pressure, fuel type, and engine oil temperature. While not quite as colorful as the Quick Dashboard, a driver can have their most valuable information in front of them. The navigation button will prompt the driver for a destination. Directions will then be given to that location. The music button will launch the user's favorite music app.
As you can see, the Quick Dashboard is displayed on beam splitter glass. The entire display is translucent, making it easy to see both the data and the road in front of you. This allows the driver to focus more on the road and eliminates the need to break their line of sight with it. With 40/60 glass, 40% of the light is reflected and 60% passes through the glass, which enables it to reflect the screen. An interesting obstacle to overcome is that since the display is mirrored onto beam splitter glass, everything is displayed in reverse. To fix this, we scaled the text objects to a negative x-axis, drew the graphics in reverse, and calculated the radial inverse for the meters.
We designed VHUD in a modular component model to allow for unlimited easy expandability through add-ons. Some expansions we have contemplated are the inclusion of voice commands, speak to text, and the inclusion of an infrared camera to improve driver safety at night by giving a broader area of view. Even though we do not have time to develop these components, we hope to see the industry expand on what we have started. With reflection upon our project, we feel that we have accomplished our goal and are excited to present the world VHUD, our solution to a safer driver and a more integrated driving experience. Thank you for watching our video. We are Project VHUD from the Capstone Engineering course at the University of Nevada, Reno, under the instruction of Dr. Daskaloo and our team advisor, Mr. Richard Kelly.